This is the fault that just struck Mexico with a magnitude 7.3 earthquake and a tsunami warning. And this, a few hundred miles up the same coastline, is a nearly identical fault sitting right off the shores of the United States. Same kind, same trigger, except the American one is larger. It's locked, and it has been silently loading for over 300 years. What happened off Mexico recently was not just a foreign disaster. It was a live rehearsal for something waiting to happen here. This is not fear for its own sake. It is the same physics, the same class of fault, watched by the same satellites. And for once, the comparison is not an exaggeration. It is almost exact. So let's make good on that comparison right away before anything else. The Mexican quake happened where one slab of the Earth's crust is diving underneath another, a setup geologists call a subduction zone. It is the single most dangerous kind of fault on the planet because it is the only kind that can unleash the true monsters, magnitude 9 giants, the same class of quake that devastated Japan in 2011 and Indonesia in 2004. And a magnitude 9 is not simply a larger 7. The scale is deceptive. Every whole number up means the ground shakes about 10 times harder and releases roughly 30 times more energy. So, a magnitude 9 is not twice a 7. It is close to 1,000 times more powerful. That's the leap between what struck Mexico and what the American fault can deliver. The United States has one of these loaded and waiting. It is called the Cascadia Subduction Zone, and it runs just off the coast of Oregon, Washington, and Northern California. This fault is bigger than the one that just moved under Mexico, fully capable of a magnitude 9, and able to do far more than flatten cities with minutes of violent shaking. A wall of water would follow, racing toward the American coast. Mexico just showed us the small version of a threat the Pacific Northwest has been quietly carrying for centuries. Now, let's understand exactly why, starting with what the Earth actually did recently. Just off the coast of Chiapas in southern Mexico, near the border with Guatemala, the seafloor lurched. The U.S. Geological Survey measured a magnitude 7.3, striking shallow, only about 9 miles beneath the surface. Shallow quakes are the cruel ones because their energy has almost no distance to fade before it hits the world above. The shaking rolled outward for hundreds of miles, felt all the way from Mexico City to El Salvador, and it was followed by a string of powerful aftershocks above magnitude 5. Almost immediately, the warnings went out. Mexico's Navy told people to get away from the beaches, and a tsunami alert was raised for the coasts of Mexico and Guatemala. This was not a fluke event in a random place. It struck nearly the exact spot where a magnitude 8.2 monster hit in 2017, a quake that killed dozens and sent a tsunami into the coast. This stretch of ocean floor is one of the most seismically loaded places in the Americas, and it had simply reached its breaking point again. To be clear, this was not the worst case. A magnitude 7.3, as violent as it sounds, released only a few percent of the energy of that 8.2 in 2017. But that is exactly what should give us pause. The same locked boundary can build up strain, fire off a major quake, and begin reloading for the next one, all within a single human decade. The reason it behaves this way comes down to a single, relentless process happening far below. And once you understand it, you understand the threat to America too. Off the western edge of the Americas, a slab of the Pacific seafloor called the Cocos Plate is being dragged downward, forced underneath the continent at a rate of about 3 inches every year. That sounds gentle. It's anything but. The two plates do not slide smoothly. They catch. They lock together along their contact, gripped by unimaginable friction, while the deeper rock keeps pushing. There is a grim detail buried in this. While the two plates stay stuck, the edge of the continent is slowly dragged downward, bending like the end of a diving board pressed from beneath. The coastline quietly sinks by fractions of an inch every year, hoarding the strain until the day it tears free and snaps back upward all at once. Think of slowly bending a wooden ruler between your hands. For a long time, nothing happens. The ruler just bends, storing more and more energy, looking perfectly stable right up until the instant it snaps. A subduction fault is that ruler, scaled up to the size of a coastline, storing centuries of pressure. When it finally lets go, all of that stored energy is released in seconds, and the edge of the continent lunges violently forward and upward. That upward jolt is the part that makes these quakes uniquely terrifying. When the seafloor suddenly heaves upward, it lifts the entire column of ocean sitting on top of it. That displaced water has to go somewhere, and it races outward in every direction as a tsunami. This is why subduction zones, and only subduction zones, can drown a coastline hundreds of miles from where the ground actually broke. And this is the uncomfortable truth. What just happened in Mexico was the small version. The fault waiting off the American coast is longer. It has been locked for far longer, and it is capable of releasing something on a scale the modern United States has never once experienced. To see what that really means, we have to travel north to the quietest, dangerous place in the country. Off the Pacific Northwest lies a fault so still, so silent that for decades no one even realized how dangerous it was. The Cascadia Subduction Zone stretches for roughly 700 miles, from northern California up past Vancouver Island, and along its entire length the seafloor is being forced under the continent in exactly the same way as off Mexico, only on a far grander scale. We know exactly how violent it can be, because we know the last time it broke. On the night of January 26, 1700, the entire fault ruptured at once in an earthquake of around magnitude 9. The shaking would have lasted not seconds, but 3 to 5 brutal minutes. That single rupture launched a tsunami so large that the wave swept clear across the Pacific Ocean and slammed into the coast of Japan, recorded there with no local quake to explain the wave. The Japanese called it the orphan tsunami. In truth, it was a message from America's own coastline. To picture what a repeat would do, emergency planners have modeled it, and the numbers are staggering. A full Cascadia rupture could kill many thousands, drop bridges and highways, and cut off the entire coastal strip west of the main interstate for weeks. Everything from northern California to the Canadian border would feel it in the same instant. It's widely regarded as the worst natural disaster that could realistically strike the continental United States. The geologic record shows this has happened again and again, roughly every few hundred years, with the gaps between ruptures averaging around 240 years. The last one was over 320 years ago. In plain terms, Cascadia has already run past its average, and recent studies estimate a meaningful chance, roughly 1 in 6, of a magnitude 9 striking within the next 50 years. When it does, the tsunami is expected to reach the Oregon and Washington coast in as little as 15 minutes, with walls of water modeled between 20 and 40 feet high. This is the disaster Mexico just gave us a small, sharp preview of, and astonishingly, it's not even the only giant the West Coast is sitting on. Because just to the south waits a different kind of monster, and this one you have almost certainly heard of. The San Andreas Fault, running about 800 miles through the heart of California. It's not a subduction zone. It is a strike-slip fault where two plates grind past each other sideways, the Pacific plate sliding northwest against North America. It can't make a magnitude 9, and it will not create a Pacific-wide tsunami. But this fault runs directly beneath the feet of tens of millions of people, through the outskirts of Los Angeles and San Francisco, and its southern stretch has not released a major earthquake in over 3 centuries. That southern segment is locked, straining, and widely considered overdue for the rupture Californians simply call the big one. The last time the southern San Andreas broke with real force, California was not yet a state. The last great rupture farther north leveled San Francisco in 1906 and set much of it on fire. In the time since, the population living within reach of the fault has swelled into tens of millions, while the pressure beneath their feet has never once stopped building. And there is a genuinely unsettling twist that only came to light very recently. A study published in 2025 found evidence that Cascadia and the northern San Andreas have been rupturing in sync for thousands of years. That when the Great Subduction Fault lets go, it can shake the neighboring San Andreas loose within minutes to days. Two of the most dangerous faults in North America may be quietly connected, capable of a 1-2 punch. That finding is still debated, and that debate matters because it sits right on the edge of a much bigger and much more misused idea. Whenever a large earthquake strikes anywhere on Earth, a familiar claim spreads within hours that this quake somehow triggered the next one, thousands of miles away. That Mexico or Venezuela is loading the gun for California. It is a seductive idea. It's also, for events that far apart, simply not how the planet works. Earthquakes can nudge their immediate neighbors. The stress release on one fault can shift onto an adjacent one nearby, which is exactly what the Cascadia and San Andreas study describes. Faults that are almost touching. But a rupture in Mexico, transferring its energy to a fault in California across thousands of miles and a completely different plate boundary, has no known physical mechanism behind it. The connection between these regions is not a chain reaction. It's something more sobering. They are all riding the same vast system, the Ring of Fire, the belt of grinding plate boundaries that encircles the entire Pacific Ocean. Mexico, California, Cascadia, Alaska, Japan. None of them sets off the others like dominoes. Instead, each one is a separate pressure gauge on the same restless machine. And every major quake is a reminder that the whole rim is alive and loading at once. So if we cannot predict these ruptures, how do we watch a fault that gives almost no warning? The answer, fittingly for a threat this large, is from space. Radar satellites now sweep over these fault zones from orbit, measuring the exact shape of the ground below to an accuracy finer than the width of a fingernail, less than half an inch of movement or even less per year. Using a technique called InSAR, scientists can watch the crust around Cascadia and the San Andreas slowly bend and strain in the years between earthquakes, mapping precisely where the fault is locked tight and where the pressure is piling up. We are, in effect, taking the pulse of the planet from hundreds of miles above it. And the tools are only getting sharper. A powerful new radar satellite, built jointly by NASA and India, now scans nearly the entire surface of the planet every few days, hunting for the faint swelling and sinking that betray a fault under strain. Paired with ground stations that track the crust using satellite navigation, it means the most dangerous faults in America are, for the first time in history, watched almost constantly from orbit. And that pulse is the real story here. Earth is the only world we know of with active plate tectonics, the only rocky planet whose surface is broken into moving, colliding, diving slabs. On Venus and Mars, the crust is a single dead shell. Here it lives. The same relentless engine that builds our mountains, recycles our crust, and may have helped make our planet habitable in the first place, is the very thing that shook Mexico, and the very thing loading the faults off California. The danger and the life comes from the same source. None of this is a prediction that the big one strikes tomorrow. No one can promise that in either direction. What Mexico delivered recently was not a countdown. It was a reminder, sharp and impossible to ignore, that the western edge of North America is one of the most heavily loaded stretches of ground on the planet, and that the quiet is not safety. The quiet is the fault holding its breath. Today, the ground off Mexico finally exhaled. The ground off California and the Pacific Northwest has not for centuries. And whether that release comes next year or next lifetime, the smartest thing any of us on this coast can do is treat every one of these distant warnings as a personal one. Mexico, Venezuela, Japan, every far-off rupture along the rim is in a sense the same restless boundary speaking in a different accent. And lately, it has been speaking more often. The Earth is not the only slow-moving giant we are now watching from orbit, waiting for the moment it finally breaks. Far to the north, an entire ice sheet is approaching a threshold of its own. We break down exactly what that means in What the Greenland Tipping Point Will Do to Earth by 2030. Watch that one next.